Okay, so today we're going to check out test 3 on the McGraw-Hill series, and we'll do it timed. The minimum fine for driving in excess of the speed limit is $25. An additional $6 is added to the minimum fine for each mile per hour in excess of the speed limit. Rachel was issued a $103 fine for speeding in a 55 mile per hour zone. For driving at what speed was she fined? Okay. So let's come up with a function, a linear function, to represent the fine amount. So we'll call that C of x. So the cost of x, x being the number of miles per hour over the speed limit. So it starts at $25, and then you have to add $6 for each x, where x is the number of miles per hour over the limit. Okay. So we know that the output is going to be 103 because that's the amount that her ticket was. Okay, and then we can solve for the input by subtracting 25. Okay, so what would that give? Maybe 78, and then we'd have to divide that by 6. So 6 into 78 goes once and 3 times, so the 13 for x. But x is how much she goes over the speed limit, and the speed limit is 55, so we have to add that to get 68 for her total speed. Okay. Question 2. 5x to the third times 2xy times 3xy squared is equivalent to. So the first thing to do is multiply the numbers together. Okay. So you get 10 times 3 is 30. So you could already start ruling out some choices. Now you just want to count up how many x's you have altogether. So you have 3 copies there, 1 there, 1 there. So that's a total of 5. And then for the y's, you've got 3 copies. So J is the best choice. What is the fourth term in the arithmetic sequence? Okay, so arithmetic sequences have a common difference. In this case, the common difference is -3. So you just keep going down by 3. It looks like the next term will be 4, right? When written in symbols, the product of R and S raised to the 4th power. Okay, so that's going to be H. Which of the following numbers has the digit 5 in the thousandths place? So the thing to remember here is there's no oneths place. It starts at tenths. Okay, so we have tenths, hundredths, thousandths. So choice D. Mandy and Jordan each bought some of the same notebooks and 3-ring binder. Mandy paid $5.85 for 3 notebooks plus 1 binder. Okay, so that would be $5.85. And then for 2 notebooks and 1 binder, Jordan paid $4.65. So you see here I've let N equal the price of each notebook, and therefore B would be the price of each binder, right? When you multiply the price of the binder times the number of binders, and the price of the notebook times the number of notebooks, you'll get dollars, right? So this is the amount that it costs to buy 3 notebooks. So dollars plus dollars equals dollars. That's why this equation works. So what they want to know is what is the price of one of the notebooks. So what I would do here is I'd use elimination method, and what I would do is I would negate the entire bottom equation. Then I add the lines. Okay, so the b's will cancel out. 3n minus 2n is n. And here I get 20 cents and $1. So N is the notebooks, and it's J. Good. Alright, so if Mn equals K and K equals x squared n, Nk is not equal 0. Usually you can disregard these kind of information. Which of the following is equal to M? So we want to know what M is, right? So far we know Mn equals K, and we know K equals x squared n. Okay. So one thing that seems kind of obvious is we can plug this in for K, right? X squared n. Then we could divide by n on both sides, effectively isolating M. So M is x squared. That is a choice. Alright, so here we just have to solve this equation, which should be pretty straightforward. I always like to start with the x's. so that I make sure that I'm going to have a positive coefficient on my x's. Minus 5 on both sides, and that will give me a 4. So then I divide by 5, and I end up with 4/5. What percent of 5 is 7? Okay, so you can refer to my Math English Dictionary series for more information on why everything is like that. But in general, is means equals, right? Of means times. Percent means divide by 100. Okay. So anyway, we just have to solve for x here. So we move the 5 diagonally across the equal sign to the bottom. And similarly, we move the 100 across the equal sign to the top, diagonally. Now, we do this division first. 100 divided by 5 is 20. 20 times 7 is 140. That'll be choice D. If x is a positive real number such that x squared is 16, therefore x is 4, we can just plug in 4 there. We get 64 plus 2, which is 66. Alright, so negative apps negative 16 minus 16. So first of all, the absolute value of minus 16 is plus 16, right? So we could just replace that with 16. Now we have minus a minus, which turns into a plus, right? So when you combine these two together, you get 0. Partial deck of cards was found sitting out on a table. If the partial deck consists of 6 spades, 3 hearts, and 7 diamonds, what's the probability of selecting a red card? So probability is always success over total, right? So in this case, the total number of cards, we have 7 and 3 is 10 and 6, 16. Now, to get a successful card, we have to draw one of the reds. There are 10 reds. So now we just have to reduce this. Well, this got a 2 in it, so does this. This is 2 times 5, 2 times 8. The 2's cancel, 5/8. Which of the following is a simplified form of this? Well, we can simply add these to get 7x minus 4y. Yeah, D. Gary has turtle, cats, and birds. The number of birds, let's call that B, he has is equals 4 more than, so 4 plus the number of turtles, T. The number of cats, we'll call that C, is equals 2 times the number of birds, B. Okay. Which of the following could be the total number of pets? Okay. So if you notice, we have 3 letters, B, T, and C. So we call those unknowns, right? And when we have 3 unknowns, we expect to have 3 equations. But in this case, we've only got 2. So did we do something wrong? Well, it turns out we did not, okay? We used up all the information, but yet we can't solve this, right? Luckily, they don't ask us to solve for B, T, or C, but rather for the total, which could be the total, okay? So all we need really is an expression that represents the total. So we don't have to solve. But we do have to pick what's called a master variable, and we get everything else in terms of that variable. So the best option to pick for the master variable in this case is the letter B here, because it appears in both equations, okay? So the idea is to get every unknown in terms of B. Okay? So, C is already done for us. Nice. Now, we'd have to isolate for T in the first equation. So we get B minus 4. Okay? Alright, so that's 2/3 of the way there. And then B, of course, is just equal to itself, right? So now, if I did my list of C, T, and B, right, I would have C must be 2B, then T has to be B minus 4, and then B is just itself, right? Now, to get an idea of the total, I would have to simply add these together. So I'd have to do this plus this plus this, right? And so the total would equal what? 4B minus 4, right? So there's an expression that represents the total. And what I notice about this expression is that I could factor out a 4. So it would be 4 times quantity B minus 1, right? Now, since I factored out a 4, that means that whatever the total is, it's 4 times something, okay? Which means it has 4 as a factor, and therefore it's a multiple of 4, okay? So I know the total has to be a multiple of 4. The only one that's a candidate for that in the choices is H. On a map, 1/4 inch represents 12 miles. Okay, so this is seeming like a proportion question. If a road is 66 miles, so sometimes it's helpful to write the units here. Okay, what is its length in inches? So x will be inches. So using the units helps you set it up, but once you got it set it up, you don't need the units anymore, so you can erase them. Okay, and from here, a lot of people will cross multiply. What I like to do is I like to just bring the 66 over to here, okay? But, I mean, cross multiply is fine too. So 66 times 1/4, we could just divide it by 4, right? So 4 into 66, it goes once, and bring down the 6, it goes, what is it, 6 times, we get 24. And remainder of 2 out of 4, which is also known as a half, so 0.5. So 16.5 over 12 is what we need to do for x now, right? 16.5 over 12. So it's a little more than 1, so we can eliminate these 3 choices. So the question is it 1 1/2 or is it 1 3/8? Well, let's see. What else can we do? We could double the top and bottom. So this will give us 31 over 24, right? Then that we realize that this is 1, and it looks like maybe 7 out of 24. Is that right? Yeah. So is this right? Oh, I'm sorry. This should be 33, shouldn't it? Yeah, when you double 16, you get 32, and then double a half, you get 1, so 33. So therefore, this would be 9 over 24, which we can reduce 9 over 24 by, what, 3 on top and bottom? So that's 3 times 3, and this is 3 times 8, so you get 1 3/8, which is choice D. Right, if b equals this, then a minus b to the third equals what? Okay. So, we could plug this in for b. We have to make sure to use parentheses on it, okay? Whole thing to the third. So then you distribute the minus sign. So a minus a plus 4 to the third. A minus a cancels. We get 4 to the third, which equals 64. Now, if you didn't use the parentheses, you wouldn't have distributed the minus sign. You would have had negative 4 to the third, so you would have gotten negative 64, which is incorrect. If g is an integer, which of the following could not equal g squared? Alright, so this is a cryptic way of asking about perfect squares, okay? So, right, g being an integer could be something like 1, 2, 3, 4. So then when you square that, you get 1, 4, 9, 16. Okay? So 9, 4, 1 are all on that list. And then if you square 0, you get 0. The only way that you can't get is basically 8. Alright, Justin owns 6 different dress shirts, 3 different pairs of pants, 5 different ties. How many distinct outfits can he make? So this is counting principle. Okay? So we have 6 choices for dress shirt, 3 choices for pants, 5 choices for ties. We multiply these together. 6 times 5 is 30, times 3 is 90. An oil refinery produces gasoline from crude oil. For every 10,000 barrels of crude oil supplied, the refinery can produce 6,500 barrels. So for every 10,000 barrels of crude oil, 6,500 of gasoline. Okay? So now it seems like a proportion. How many barrels of gasoline, so this is question mark, from 3,500 barrels of crude. Okay, so now that we set it up, we don't need the units anymore. Okay, and we can also cross out zeros here, which is helpful. Right, so those two zeros and those two zeros, just get rid of that comma. Now we could solve for this question mark. Let's call it x, so it's more used. We're more used to x, right? So at this point, we're going to move this 65 diagonally across the equal sign, okay? And then we're going to move the 100 also diagonally downwards, okay? These zeros can cancel with these zeros, right? And so we're left with simply 35 times 65, which we can figure out easily enough. 32 plus 15, 18, and 1 is 19. So 7, 12, 2275, choice D. What is the slope of a line that passes through the origin and this? So slope is change in y over change in x. Okay, so the change in y goes from 0 to 2, so it went up 2. Change in x goes from 0 to negative 6, so it went down 6. So together that's negative 1/3. Alright, n to the x times n to the 8 is n to the 24th. So right away I know I need to add these exponents to get x plus 8. And then I can actually drop the n's. So x plus 8 is 24. Subtract 8, I get 16. Positive 16 for x. Now n to the 6y, sorry, n to the 6 to the y equals n to the 18. So I have to multiply these exponents. That's rule 3 of my exponent rules. Okay. And then I also could drop these n's and set these exponents equal. Divide by 6 on both sides, and I get 3 for y. Now they're asking for the sum, x plus y, so I add them and I get 19. What is the slope-intercept form? So we need y equals form, right? So what I do is I bring this term to the other side, as well as this one. So when I do so, I get the opposite sign in front. Okay, so that becomes negative 9x and a plus 6. Then I simply have to divide by 3 on each item individually. I could also divide the whole thing by 3, but in this case, this option works out better. So I do 9 over 3 and get 3, still negative, and 6 over 3 is 2. So I get negative 3x plus 2. The volume of a cube is 64, and I also know the formula happens to be side cubed, right? What is the shortest distance from the center of the cube to the base of the cube? So side cubed equals 64. I can raise both sides to the 1/3 power. In other words, taking a cubed root, and I get side length equals 4. Now I imagine my cube here, and if I have a point in the center and I want to get down to the base, the quickest way is with just a straight line. That straight line will have half the length of this side, which we already know is 4. So half of 4 is 2, choice A. For the right triangle below, what is the sine of C? Okay, so the first step is to label my sides, and notice how this arc touches these two sides, so that this must be the opposite. And here is my hypotenuse and adjacent. So if I want the sine from SOHCAHTOA, I know that that's opposite over hypotenuse, right? So the opposite side is labeled A, hypotenuse is B, so looks like it's going to be choice F. What is the area of the triangle in the figure below? So area of a triangle is base height over 2. So the base measurement looks like it's going to be 5. The height measurement is 4. So I simply plug those numbers in. I do the division first whenever possible. 4 divided by 2 gives me 2 in the numerator. 5 times 2 is 10. Store charges $39 for a certain type of sneaker. this price, meaning $39, equals 30% more than. So this is a multiplier, which represents a 30% increase. So that's 1.3, the amount that it costs the shoe store. So we don't know, so we let that be C, equals the store's cost. Okay. At the end of the year's sale, sales associates can purchase any remaining sneakers at 20% off of the store's cost. So let's let S equal the sale price. So they're saying that, or I should say employee sale price. So the employee sale price equals 20% off, which again is a multiplier, that is 0.8 of the store's cost. So that's C. Now the question, how much would it cost an employee to purchase a pair of sneakers during this type of sale? So they want to know the employee's sale price. Okay. Well, so the first step is to solve for C using this first equation. We simply have to divide by 1.3. Okay. And therefore, it looks like C is going to equal 30, if I did this correctly. All right, because 39 over 13 would go 3 times, wouldn't it? Right. But then you have to move the decimal once to the left on the denominator, so once to the right in the numerator. So that would make 30, yes. So we know that C equals 30, right? And then we could plug that in here. So S equals 0.8 times 30. All right. So we can move the decimal once to the right here, once to the left here. That will balance out. So it's the same thing as doing 8 times 3, which is 24. Okay, so that's a store's employee cost for the sale. After excavating a lot, workers removed an estimated 7,000 cubic yards. So whenever you see the cubic yards, that's yards cubed. So you know that's a volume. Okay. If this dirt were spread over an even layer over an empty lot with dimensions 30 by 64. Okay, so we have a lot of 30 by 64. All right. Well, how deep would that be? Right. So the third dimension is the question mark. So we know that volume is length, width, height. And we know the length and we know the width. We want to know the height. Okay. And by the way, length, width, height are arbitrary. So, you know, I could have called this width and this length. It doesn't really matter. But anyway, I could start plugging in my numbers now. I get 7,000 equals 30 times 64 times H, right? And let's see. To solve for H, I just have to divide by 30 and 64 on both sides. Okay? So then H equals 7,000 over 30 times 64. All right? Now, since I haven't been using a calculator, I'll still try to keep it up. So let's divide by 10 on both, or in other words, cancel out zeros. 64 is really 8 times 8. That might help at some point, right? This 8 is really 4 times 2. And I know I can get at least a 2 out of this. So this is 350 times 2, right? 700. Right, so now I can at least cancel these 2's. 350. Is that number divisible by 2? I believe it is, yeah. So it would be 175 times 2, wouldn't it? And then this 4 is really 2 times 2. So these 2's can cancel. Right? And, well, there's definitely 3's in there, right? So how many 3's are in there? Let's see. Well, every 25, there's going to, let's see, how many 25's are in there? Let's do it this way. Well, how many quarters does it take for $1.75? I would say that's 7 quarters, right? So this can be written as 25 times 7. You see? Well, this is just 5's, 7, 2's, and 3's. So actually nothing else cancels, unfortunately. But we can get a good approximation from here. So we can approximately cancel out the 7 and 8, right? We know, since we don't need an exact answer, approximation is okay. Which gives us 25 over 3 times 2, which is 6. So if we made that, like, say 24, that would equal 4, right? So we know we're close to 4. And in fact, right, we should be over 4, because we had 25 over 6, right? So just to be sure, we can easily use the calculator. So 7,000 divided by 30, and then take that answer, 233, divide that by 64, and yeah, actually we get between 3 and 4. Right, so 28. The hypotenuse shown below is 17 feet long. The cosine of angle C is 35. So the cosine of C is 3 over 5. Cosine, again, is adjacent over hypotenuse. So it's going to be this over this. All right. So we could set that equal to x over 17 and then solve for x. So we move the 17 diagonally, and then we can use our calculator. Okay, so 3 times 17 divided by 5, we get 10.2. All right, so that's the value for x, which is the same as what they're asking. When the crier is arranged in rows of 5 people each, the last row is 1 person short. Okay, so this is going to be a remainder problem. Okay, so basically they're thinking of a number that when you divide it by 5, you get a remainder of 1. Sorry, you get a remainder of 4 because it's 1 person short, right? Then the next sentence, when the choir is arranged in rows of 6 people each, so that is to say when you take the total number and you divide it into 6 groups, the last row is still 1 person short. So this time we'll get a remainder of 1 less than 6, which is 5. Okay. So another way to express this is the first one is telling us that we're 1 short of a multiple of 5. Okay. So we've got multiples of 5 are 5, 10, 15, 20, 25, 30, right? And if we're 1 short of a multiple of 5, we're either 4, 9, 14, 19, 24, 29. So these always end in 5 and 0, but if you're 1 short, this class of numbers always ends in either a 4 or a 9. Okay. So now let's inspect what's happening with the second constraint. Basically here, we're going to be 1 shy of a multiple of 6, right? So we can write our multiples of 6 out, 24, 30, and then we can write 1 shy of that, 11, 17, 23, 29. And what we see is that this number appears in both groups, so that is a possible number. Right, what is the y-coordinate of the point in the standard xy coordinate plane at which these two lines intersect? Alright, so what we can do is we can set the right-hand sides equal, since we know that when they intersect, the y value is going to be equal. So we get this equals this, and then for simplicity's sake, x over 2 we can turn into 0.5, because 1/2 is really 0.5, right? We could subtract that from both sides. Okay, so 3 minus 1/2 is 2.5. Then we add 2 to both sides, and we get 5 on that. Divide by 2.5. Okay, we get x equals 2. All right, and they're asking for the y-coordinate, so we have to plug 2 back in. So 3 times 2 is 6, and we end up with 4 for the y-coordinate. So notice that you want to beware of partial answers. Okay. Next, segments B and C lie on line AD as shown below. Segment AD is 32 units long. Segment AC is 23. AC is 23. So how many units long, or sorry, BD is 27. Okay. How many units long, if it can be determined, is segment BC? So we're looking for this segment here. Okay, so with these questions, what we have to do is we have to either pick two lines that start at the same position or pick two lines that end at the same position. And then the other side is going to be sort of the difference, right? So as an example, if I was to pick the line which contains 32 and 27, right? And if I was to subtract these numbers, I would get 5. So that has to be this little white space here that is sort of the non-overlapping section. So the non-overlapping section is 5. So that is AB. So AB would have to equal 5, right? Now similarly, I could have also decided to take the 23 along with the 32, right? Their difference is 9. They start at the same position, they end at different positions. So this difference would have to be then that 9. Okay. So I've gotten everything except for the middle section. Well, I need to do one more to get the middle section. So for example, let's see. Okay, so we know that this is 5, right? And we know that the whole thing here is 23. So they both start at the same position, but they end at different positions. Their difference is 18, and that matches up with the length BC, right? Because AB plus BC has to equal AC. So my answer for BC is 18. For all pairs of real numbers m and n, where m equals this, what is n? Okay. So really here I just have to solve for n, sort of isolate n. So I get m minus 5 equals 6n, divide by 6, and I get n equals this, choice J. The figure below, the perimeter of the triangle is 12 plus 4 rad 3. What is the value of x in inches? Okay, so this is my perimeter, right? What else do I know? Well, for example, I know that this is a right triangle. I would need to figure out this third side, right? I could do so with Pythagorean theorem. So let's have a look at that. So if I do the first side squared plus the other side squared, that will equal, let's call it c squared. We'll call this c. So now I can actually square this by multiplying x rad 3 times x rad 3. Alright, or alternatively I can square each item. But anyway, x rad 3 is really x times rad 3. Okay, so it's sort of x times rad 3 times x times rad 3. So I could choose to do the x's first, you see. That would give me x squared. And then I could do the rad 3 times rad 3, and I get rad 9, and rad 9 of course is equal to 3. Okay. Now here I have like terms. 1x squared and 3x squared is 4x squared. And then to finally find out what c is, I have to square root both sides. Okay. So when I square root this side, I can do it separately. So I do rad 4 and rad x squared. Rad 4 is 2, rad x squared is x. So c is equal to 2x. So now instead of writing c here, I could write 2x. Now from here, I can come up with an expression in terms of x for the perimeter. It would simply be x plus 2x plus x rad 3. And again, here I can combine these like terms to make it 3x plus x rad 3. Right? And now I can set that equal to the value I have for the perimeter, which is 12 plus 4 rad 3. And what you notice is you have one term that involves rad 3 and one term that doesn't. So the terms that do not involve rad 3 must equal each other. And similarly, the terms that do involve rad 3 must equal each other as well. So I'll write that over here. X rad 3 equals 4 rad 3. So solving this, I divide by rad 3 both sides, cancels out both sides, x equals 4. And if I solve this, divide by 3, I get x equals 4. So either which way, I get the same result for x, which is 4. Now, one quick shortcut here is if we noticed this is x rad 3, right? So the other one, of course, would be 2x for a 30, 60, 90 triangle. So it's the ratio of sides for 30, 60, 90. So if we recognize that, then we would have been able to find this missing piece right away, and we would have been able to jump down to this portion of the problem. In the figure below, xy equals yz. Okay. If a equals 40, what is xy? Okay. So the first thing to notice then is we can of course figure out the other two angles if we need to, but in fact we're not actually going to need to here, because the way to solve this is, since it's an isosceles, we can drop a line down here. This is going to be an altitude, so it's going to be perpendicular. It's also going to be a median, and it's also going to be an angle bisector. So we can actually write that this is going to be 20 degrees. This is 20 and this is 90, so therefore this must be 70, right? 70 and 20 adds up to the other 90. So now we've got a right triangle here, and we know this is going to be 2.5 along here, because since it's a median, it's half of 5. So anyway, we have this nice triangle here with 2.5, with 20, and with 70. It's a right triangle, so we can use right triangle trigonometry to figure out this side. So for example, if we use the 70-degree angle, this would be the adjacent and the hypotenuse. So we can use the cosine of 70, and that will equal adjacent, which is 2.5, over hypotenuse, which is x. Now I can move the x diagonally across the equal sign to be there. And then I can move the cosine 70 diagonally, and it would land over here. Okay, so now I just have to put that into the calculator, so let's load it up. So 2.5 over cos 70 is 7.3. Some odd reason that's not a choice, but I think this may be a typo on this one. In the coordinate plane, what is the y-intercept of this line? Okay. Right, so we have to get y equals form. So best way perhaps to do that is to move this 3y over to here. Okay. Then we can move the 15 to the left, making it minus 15. Alright, then we could divide by 3 on each and every item separately. Okay. And so we get negative 9 over 3, which is negative 3x, minus 5 equals y. And of course this would represent the y-intercept. The product of two integers is between 137 and 149. Which of the following cannot be one of the integers? Okay. Well, let's see. In this case, let's just try the choices. Alright. So from 15, we can say, alright, if I multiply that by 10, I get 150, which is close to being inside this interval. So maybe I'll go one less. If I do 15 times 9, let's see what I get. So 9 times 5 is 45. 1 times 9 is 9, plus 4 is 13. So I get 135. Okay, so it seems like I skipped this entire interval, right? I was too high at first, and then I was too low. So it seems like I cannot have my integer be this, because then I would just skip right over the interval. Right, so here's another remainder question. When x is divided by 7, the remainder is 4. What is the remainder when 2x is divided by 7? Okay, so let's see. I have to think of a number that satisfies this first requirement. So let's try to think of a number that when we divide it by 7, we get a remainder of 4. Any ideas? Well, basically what we have to do is we have to look at the multiples of 4, okay, and then realize if we want to get a remainder of 4, we must be 4 higher than this number. So 11, 18, right? 4 higher than this would be 25. So any of these numbers will do, okay? And in fact, the easiest possible number you can pick, if you start from 0 as the first multiple of 7, 7 times 0, if you add 4 to that, you get 4, right? So generally, that's the number that I'll always pick for this type of task, is I'll just pick the remainder itself. Okay, it's a little trick. So then you can plug that in for x. You get 2 times 4, and that's 8. So what is the remainder when 8 is divided by 7? Well, that's equal to 1, remainder 1. So choice A. A circle is circumscribed within a square with sides of 12 feet. What is the area of the circle? So the area formula is pi r squared. Okay. This represents the diameter, so the radius would be 6. Pi 6 squared is 36 pi. Now pi is something like 3. So 36 times 3, it's going to be like pretty close to 100. Well, that would be what? 118? Or 108 rather. So yeah, 113 seems good. Right, so here's a consecutive numbers problem. So whenever you see this kind of a problem, we always let x represent the first consecutive number. Then the next one will be x plus 1, then x plus 2. This time we need to go all the way up to x plus 6. So that will represent 7 different items, 7 different numbers. Now in this case we need to take an average of those numbers. So when we do an average, the formula is sum over number. Okay? So the first step is to take the sum of all these items. So when we add up all the x's, that's going to be 7 x's. And then from 1 through 4, that equals 10. And this equals 11 together, so that's 21. So that's my sum, right? So that will go in that position of my formula. We know that the average is going to equal 16. So we also know that there's going to be 7 integers altogether. So now we just have to solve for x. So there's a few ways to do it, but one tricky way, I guess, is you could divide each of these pieces by 7, right? Think of this as a common denominator, okay? So 7x over 7 is just x. 21 over 7 is 3. Subtract 3, and that'll get you 13 equals x. And now we have to be careful here about what they're asking for in particular. It says the sum of the least and the greatest. So far we've found only 13, which is the least number. Okay. Now we want to find the greatest number. We plug 13 in. 13 plus 6 is 19. Then finally we have to sum these together. And what does that give? 32. Right. So again, we have to be aware of partial answers. Okay. Next, in figure below, ABCD is a trapezoid. Okay, blah, 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 blah. So we want to find the marked angle. So the first thing I notice here, we have sort of parallel lines, right, cut by this transversal. So whenever we have that being the case, we always can form alternate interior angles, and they're going to be congruent. And then, of course, we have here a straight angle, which has to add to 180. As you can see, it's half circle, right? Circle's 360, half circle's 180. So that means if I call this x, that means that 25 plus, so 25 plus x plus 125 has to equal 180. So that's 150 plus x is 180. Subtract 150 and I get 30 for x. Then I just have to make sure I'm answering the right question. Yep, BDC. Good. For which of the following functions is f of minus 5 greater than f of 5? Okay. So one way to do it is to plug in negative 5 and 5 for all these functions. That's a bit tough, right? Not really tough, but more time consuming. So another way to do it is to sort of look at what each function would look like as a graph. So you could either graph them in your calculator, or you could sort of know what each graph would look like. So we can sort of get a somewhat picture of each graph. We know this is going to be a hyperbola, so it's going to have this sort of characteristic. And choice D is going to be a cubic function with an intercept of plus 6, and it's going to be a negative cubic. So that means instead of having a positive end behavior, it'll have a negative end behavior. And finally, choice E is a even polynomial of degree 6. So that means it's going to be a really tight-looking parabola, sort of esque object, which flattens out in the middle. But again, we're just looking at qualitative sort of information here. Something like that is good enough. Okay. So, yeah, so basically this is the left and this is the right, right? Because when you input -5 in for your x value, that's the left part of the graph, somewhere here, and then the right, okay? So we want the left side to be higher than the right. That's what they're saying. The only function that satisfies that property is d, right? Now, there's another way you could look at it with the idea of even and odd functions, okay? So, if you notice, choice A is an even function because of the x squared, right? So we're just looking really at the exponent here of the polynomial. So that's even, right? Even means that it's going to be symmetrical with respect to the y-axis, so that any negative value is actually going to equal the value sort of the same distance on the right. Okay. So notice that b is also an even function because technically there's an x to the 0 that's missing there, right? And you can see it has symmetry about the y-axis. So even is no good because we want it to be sort of not symmetrical, right? And finally, also e would be even because it has two pieces, both of which are even. Okay. So now these functions happen to be odd, right? So this is x to the -1 power. So that's going to be an odd. And then x to the third is going to be odd as well. Well, not quite odd. It's going to be shifted. But anyway, it's going to have some odd type of behavior. In other words, it's not going to be even. So let's just say it's neither. Anyway, let's see. So yeah, if we only knew that, we'd be down to these two choices, right? And then you notice sort of, yeah, that when you plug in to here, that's when you're going to get the, yeah. Well, anyway, that's enough for that one. For what value of n would the following system of equations have an infinite number of solutions? Right, so there's three sort of different types of solutions for linear systems, right? So the solutions are the intersection points of these two lines. And it could happen at one place. We call that one solution, right? It could also happen sort of not at all, right? So this would be 0 solutions. And the third possibility, right, is that we can have the same line twice, in which case we have an infinite number of solutions, right? So if we have an infinite number of solutions, we're in case 3, okay? So case 1, case 2, case 3. So we have to have the same exact line, which means that we're going to have the same exact equation twice. So we must demand that these two equations be identical. So the way to actually get closer to that is to multiply through by 4 here. We'll get 12a plus 4b equals 30, no, not 36, 48. Okay? And now the left sides are equal, but we also need that the right sides has to be equal. When we divide by 3, we get n is equal to 16. So that'll be our answer. All right, if x and y are positive integers such that the greatest common factor of x squared, y squared, and xy third is 27, then which of the following could y equal? All right. So we'll do a quick review on what a GCF is, right? So if I have the numbers 12 and 8, what I would do is I'd factor these numbers down. 4 times 3, 2 times 2, 2 times 4, 2 times 2. So once I get all primes, okay, then I could rewrite it as 2 squared times 3. This one I could write as 2 to the third, and I'm going to include a 3 to the 0 power here. You'll see why in a second. Of course, 3 to the 0 is 1, so I'm allowed to include it. So the next move that I will do is I will stack these on top of one another, and then I can get my GCF and I can get my least common multiple. So for GCF, that is greatest common factor, I actually want to take the least of each column. So the least would be 2 squared, and the least here would be 3 to the 0. And then for least common multiple, I actually want to take the greater of these columns. It's kind of opposite of what you would think. Okay? And then I could just multiply it out. So 4 times 1 is 4, and 8 times 3 is 24. So the greatest common factor is 4. The least common multiple is 24. So that's the characteristic of those numbers. Now the same thing can be done with these monomial expressions. Okay. The difference is that they already sort of factored it for us. So that's nice of them. So we could already stack these on top of one another. And then for GCF, remember, sorry, let me just write this clearly. For GCF, we want to take the least of each column. So the least of the x's would be x to the first, and the least of the y's would be y squared. Right? So basically, the GCF is equivalent to xy squared. And we know that that's equal to 27. And of course, we can actually factor 27 down into 3 times 9, and then 9 into 3 times 3. So if we just decide to group those together, we get 3 times 3 squared, which is kind of a weird way to do it, but you'll see why I do it that way in a moment. 3 times 3 squared. Because now you can see that the x will match up with a 3, and the y will also match up with a 3. Alright, so y could equal 3. What is the smallest possible integer for which 15% of that integer, so 15%, we move the decimal twice to the left, of means times that integer, so we don't know it, so it's x, is greater than 2.3. So we just simply divide by 0.15. Right? So we do, let's see, 2.3 divided by 0.15, and that will give 15 1/3. Right? So x has to be greater than 15.3. So the closest integer that is greater than that is 16. What is the distance between these 2 points? Okay, so we find delta x and delta y. That's step 1. So the change in x is 4, the change in y is 3. And then we do a Pythagorean theorem on these guys. Right? So here's your new distance formula. Okay? Well, it's just going to come out to 5, isn't it? Because we know that 3, 4, 5 is a Pythagorean triple. The sides of a triangle are 9, 12, and 15. 9, 12, and 15. What is the angle between the two shortest sides? So we could use a sort of trig operation here, because we know, let's see, do we know it's a right triangle? We're not supposed to, but we can actually see that it's 3 times 3, 3 times 4, and 3 times 5. So it's a multiple of a 3, 4, 5, and a 3, 4, 5 is a right triangle. Right? We can also verify it just by using Pythagorean theorem. Okay. But anyway, so we know that this would be a right angle across from the largest side. So that means that the angle between the two shorter sides is 90 degrees. In the pentagon below, one interior angle measures 40. What is the total measure of the other 4 interior angles? Okay. So we have a formula for the sum of interior angles of a polygon. Right? And if you don't remember the formula, you could actually remember it this way. Start with a triangle. We know that it adds up to 180. Then we go to a square or rectangle is 360. Now you may not know a pentagon, but you have sort of 2 possible trends. Either it doubles every time, or you add 180. And if you doubled every time, you get really large really fast. So we don't want to do that. We just want to add 180 each time. Okay? So eventually we can get to how many this is, which is 5-sided. We know that's going to be 540. Right? So if all of them add up to 540, and we already accounted for 40, that means there's 500 left. Okay? That's going to be choice D. For real numbers R and S, when is the equation abs R minus S equal to abs R plus S true? Okay. Well, let's try to think of some numbers here. So what can we pick for R and S? How about we pick 1 and 1? So 1 minus 1 is going to be 0, and then 1 and 1 is going to be 2. So it's not true for this grouping. So I could cancel out always, right? When r equals s, well, that's still not true in that case. And these I haven't explored yet. Alright, so now I'm going to choose different group for my numbers. So this time I want to choose, let's see. Well, let's choose 0 and 1. So r minus s is 0 minus 1, negative 1, absolute value of which is 1. Then I do 0 plus 1, absolute value, I get 1. So I found a way to make it work, okay? And so it's true only when r equals 0 or s equals 0. Well, kind of, right? From what I have here, it's true only when r is greater than 0. Is my r greater than 0? No. So I could eliminate that. And it's never true, I could also eliminate that, because I found a way to make it true. Therefore, it must be h. What is the value of this? Well, this you could do several different ways. I like to use my left, right, center method. Right? So let's say with this equals x, we grab the left, then we grab the right, and then we grab the center. So 4 to the x equals 64. So what power of 4 is 64? It's the third power, right? If you didn't want to do it that way, and you wanted to use the calculator, you could use the change of base formula, right? So you could do the log of 64 and divide that by the log of the base. And that'll give you the same answer, 3. How many different positive 3-digit integers can be formed if 3, 4, 5 must be used? Well, I have got 3 choices for the first integer. I could use any one of those. Then I need to use one of the remaining 2, and then I need to use the remaining 1. So there's 6 different ways to do it. Alright, so they want me to solve this. So I'm going to subtract x from both sides. That cancels out. And then I get negative 3 is less than negative 5. Is that a true statement? No. I would say that that's false. Okay? So it's false regardless of what I choose for my x value. So therefore, the only way to make it true, well, there is no way to make it true. It's the empty set. What is the slope of the line that is perpendicular? So we need to get y equals, right? So we could swing this over to the other side, negative 7x plus 11, and then divide by 4 on each and every item. So we get negative 7/4 as our slope. Then we need to do a negative reciprocal of that, so we get 4/7. That's how we get a perpendicular line, is we do a negative reciprocal. If each element in a data set is multiplied by 3, and each resulting product is then reduced by 4, which of the following gives the mean of the resulting data set in terms of x? It must be this, because I can make my set all 1s, right? And as a matter of fact, I can even make my set just the number 1. Alright? And then, so if this is my set, I take each element of my set, I multiply that thing by 3, and then I subtract 4. Alright? So this is the idea of plugging in. Okay? So if you're not sure, you can do it that way. Alright, so this one we're going to need a grid, and we're in the second quadrant because this is 90 and 180. Okay, 90, 180. You can convert that by knowing that pi is 180 degrees. Pi radian is 180 degrees. Okay. The cosine of this angle is negative 3/5. So cosine is adjacent over hypotenuse. Then what's the tangent? So this is going to be a 3 blank 5, so 3, 4, 5 triangle. This 4 is positive. So the tangent is opposite over adjacent, so it's 4 over negative 3. Choice G. City Council has approved the construction of a circular pool in front of City Hall. The area available for the pool is 12 by 18. Large as possible. Okay. Right, so we need to put a circular pool here, and we need to leave 2 feet on each side. So in particular, the most restricted side is the vertical. So really I need to leave 2 here and 2 here. So then I can get the diameter of this. So the diameter plus 2 is going to equal 12. Diameter plus 4 equals 12, so diameter has to equal 8. Therefore, the radius would be 4. Alright, so the time elapsed, it's already at 1 hour, but that was due to a lot of explaining of stuff, you know. Kate rode her bicycle, alright, mostly uphill and took M minutes, okay, so that was on the way there. On the way home, she rode downhill, and her average speed was twice that, okay. Which of the following represents the total number of minutes? So if she went twice as fast, it should take her half as much time. So her time on the way home should be m over 2, right? So then if I want to get the total amount of time, I add the original m with the m over 2, and I need a common denominator, so I multiply by 2 over 2 here. So then I get 3m over 2 as my total time. Let n equal this. What happens to the value of n if the value of a becomes 2 greater and b becomes 1 less? So I could substitute this in along with this. So I get this plus 2 times this minus 7. Then I distribute 3a plus 6 plus 2b minus 2 minus 7. So I get 3a plus 2b, right, minus 7. The only new parts are this and this. Those new parts combine to make plus 4. So I have here the original plus 4. So I've increased the original by 4. In the figure below, triangle ABC is a right triangle with legs that measure x and 3x. What is the length of the hypotenuse? So we already saw a question that was sort of similar to this earlier. Alright, so we just have to do Pythagorean theorem. Alright, so when we square the 3x squared, we get 9x squared because we have to square both pieces individually. Alright, then we do 1x squared plus 9x squared, we get 10x squared. Then we have to square root both sides. When we do so, we square root the 10, and when we square root the x squared. So we get rad 10 times x. Choice F. If the edges of a cube are tripled in length to produce a new larger cube, then the cube's surface area is how many times the original? Okay. So we need a surface area formula for a cube. And it turns out what we have to do to get it is to sort of see how many faces there are. Namely, there's 6, right? And to take an area of each one. So the area of each one is side squared. So if I add all those together, I get 6 side squared for my surface area. Right? So now that we have a formula, the question is, if I take the side length to become 3 times the original, what would be the effect on the surface area? Well, there's a few ways I could do it, right? I can substitute in, just as we did in a few problems ago. So let's try that first. So instead of s, I'm writing 3s squared. Okay. So now each item gets squared, and I get 9s squared. So this extra factor of 9 is timesing the 6s squared, which is the original. So it's 9 times greater. Choice B. Considering all values of a and b for which a plus b is at most 9. So at most is code for less than or equal, right? A is at least greater than or equal to 2. B is at least negative 2. B is greater than or equal to negative 2. And what is the minimum value? B minus A. Okay? Alright, let's see what we could do. So, let's see. Alright, so if we want to minimize this, let's start here. In order to minimize this value, right, notice first of all that A has to be greater than or equal to 2. So we'd want to make this number as small as possible, right? Seeing as it has to be a positive number. we may as well make sure that it's 2. Because if it were 3, let me think about this for a moment. Sorry, let's start with this one, right? So, alright, so b is greater than or equal to negative 2. So if this was negative 2, yeah, we'd want this to equal negative 2, right? Because if it's greater, then it's going to be negative 1 or 0 or positive 1. And we want to minimize this, so we want it to be as negative as possible, okay? So making this negative 2 would be a good decision for us. Now we have a minus sign, and then we have to decide what we're going to put here, right, for a. So for a, we could put a number as big as possible, like we can put 100 positive, because there's no real constraint here. A is allowed to be as big as possible, okay? And that's going to give us a negative 102. But the problem is that this 100 is not allowed based on the first constraint, this one, right? So if we solve this for a has to be less than or equal to 9 minus b, right? And we've decided that we're going to use negative 2 for b, so we could plug that in, and 9 minus negative 2 is 9 plus 2, which is 11. So a has to be less than or equal to 11 as that constraint. So let's put in 11 and see what we do, right? So if we do that, we end up with a negative 13 for our minimization function.